Students, good evening and welcome to APJ Academy. Hope you all are doing well and good, right? So, as you have seen in the thumbnail, today we are going to discuss a new topic and chapter. We are beginning a new chapter that is one of the most important chapters from physical chemistry, that's thermodynamics. So, uh, let's get started. Let me open my YouTube so that I can connect you there if you have any doubts or clarification required. Okay, yes, I think you can clearly see me as well as you can okay, I think now you can clearly see me as well as you can clearly hear me, right? So let's get started. Okay, so dear students, once again welcome to APJ Academy, and this is our full year course. So after watching the lecture, you believe that these classes or this whole APJ team, you believe that we can bring the best outcome for you for your next year's NEET. And if you like the content, if you like the way we teach, if you think that you stay with us for the next 1 year, you can score a very good rank and you can gain a seat in AIMS. Okay, so you can enroll for our full year course. So if that is in that case, you may require certain informations regarding our full year course. So these are the info regarding our full year course, that is what all things we provide, right? You can see that we have the complete modules, right? And question banks. Then we provide the major test series. That means we conduct 25 test series because we know that test series are the key for scoring good marks in your actual NEET exam. So before appearing for the NEET exam, you have to write more and more mock tests. So mock tests will always give you that environment, that atmosphere, and will help you trigger your mental strength and your analytical skill, and it will enhance your problem solving skill. And all this skill can be developed by proper test attending the test series. So that's why we provide that. And next you can see that the query solving, we know that in the long run we have surely we will have lots of doubts. So have a clear query solving sessions teacher in each 2 days. So in each 2 days you will be given a teacher and you can ask any queries, any doubts, you can clarify that. That's a wonderful feature that we have. Then we have lessons. Okay, so up to 20 lectures with theory explanation every month. We are going to give you 20 lectures just for theory. Okay, then after each and every lesson you will be given the assignments in order to test how you have attended the session, how much you have understood, what all concepts you have doubts, and all these things can be cleared only when you give the assignments. So this is a whole package, and you will be amazed to know the price. That is, we are providing this whole 1 year course just for rupees 490 per month. Okay, so you can crack JEE or you can crack NEET with this enormous discount, and that's the most striking feature that we have. Okay, and one more thing, if you are a regular viewer or if you are viewing this YouTube channel for the first time, I would request you to see this channel or see this session just for 10 or 15 minutes, And if you find that this is useful for you, and I am totally sure that it will be useful and will surely add value to your preparation, in that case you can subscribe to this channel, and also you can share it with your friends who are similar like to you, that they are also NEET aspirants. Okay, so they can also gain more value addition to obtain for them also. Okay, so we are regularly providing free classes, so you can subscribe it, that you may not miss out, and also click the bell icon that you may not miss out any lectures that we are, right? And that's about me, my name and my qualification, my achievements, everything given there. You can read about me there, right? Now I'm not taking too longer. Let's get started with thermodynamics. It's one of the most important as well as most beautiful chapter, physical chemistry. Thermodynamics. Thermo means temperature, dynamic means motion. So thermodynamics is the movement. It's all about the changes in energy. Okay, so temperature, or it's a form, heat is a form of energy, or it's a medium of energy. So it's all related to the changes in energy, or we can say that the changes in heat. Okay, heat changes. So let's get started. Actually, let's understand what is chemical thermodynamics. You know, chemical thermodynamics, actually it's a branch of chemistry. Okay, and what does this branch? This branch actually deals with the heat changes associated with chemical reactions. We know that there are two different types of reactions based on heat changes, that is endothermic reaction and the other is exothermic reaction. And exothermic reactions are those reactions in which, when a reaction happens or when a reaction takes place, energy will be released to the surrounding. Okay, to the surrounding. So that is called as exothermic. So whenever an exothermic reaction happens, we understand that the obtained product will be more stable than that of the reactant molecules. And similarly, if you consider about endothermic products or endothermic reactions, so for endothermic reactions you require constant heating. Constant heating is required in order to undergo certain reactions, such reactions. So in those reactions they absorb energy, and the products are formed. Okay, so products have high energy than that of reactants. That means products will be, those having higher energy will be unstable, right? We have studied chemical bonding and also in atomic structure. In actually in chemistry, if the minimum potential energy is a symbol of stability. So minimum energy is the condition of stability, right? So exothermic reactions always provides stable products, and endothermic reactions always, I cannot say it always, but in many cases, or we can say generally, they provide unstable products. I'm saying it as unstable product with respect to reactants because of the difference in energy level. Okay, in such cases, if the products are unstable, then there is a chances for the products to come back to the form of reactants. So if that happens, then the reaction will become what? Will become reversible reaction, and eventually it ends up at the condition called as chemical equilibrium, and we will study that chapter after this thermodynamics. Okay, so let's delve deep into the topics. First, let us understand the basics of thermodynamics. So, for understanding the basics of thermodynamics, oh, Protej, good evening. My health is still not that good, but I am fine. Teach on blackboard, please. Actually, I am a bit comfortable with this one. Right. This looks cool, no? Instead of turning backside and writing, I can face you. At the same time, I can write things on this board. This is white. I'm writing with the black pen, so that it is more attractive, I think. Okay, let's do with this itself. Okay, so now let's start from the basics. That is, we are going to discuss about system and surrounding. So dear students, system means, if I'm considering this a pen, okay, this is a pen, and I'm an observer, and I'm observing this pen, means all my concentration is about this pen. Okay, I'm making all the observations, I'm doing all the investigation. I have habit of learning that way. Protej, you have to change your way. Don't adapt to that. Okay, you have to learn all the ways. Okay, you should not stick on to just one thing. Okay, because now the technology is growing, not like the last decade. Okay, the very next 1 or 2 years, we not know what revolution is going to happen in the. So anything can happen. So you should not be like that. My advice is for you that take that thought from your mind and throw away. Okay. So be comfortable with this also. Tell to your mind, yes, I am comfortable with anything that's in front of me. That's the way you have to deal the modern times, right? Okay. So this is the pen. So I am the observer. I am observing this pen. I am making the investigation. I am investigating about this pen. That means, according to me, this pen is my system, and the whole universe surrounding this pen, what? The surrounding. Okay. So actually, there is a separation between the system and the surrounding. What is that separation called? That separation is called as boundary. So you know that if I consider container and I pour certain solutions in that container, say if I add some acid and I add some base, so I know that that is the system which I am focusing. I am the observer. So I am focusing on that particular container. Okay, so in that case, this is the system. This container is my system, and the whole area around this, even including the universe, that is the surrounding of this system. Okay, and the glass coating or the glass boundary or the glass coating is the boundary of system and the boundary between the system and the surrounding. So this is all about system and surrounding. Hope this is clear for you. Okay, so you can read it here. System is the part of the universe which is under observation or investigation. So if you want to study about a particular object or a particular reaction, so what reaction or what container you are looking at, that is your system. And except that, everything is your surrounding. So between surrounding and your system, there should be a boundary, and that boundary can be of different type, can be a real boundary, can be an imaginary. Okay, boundary can be a real one or it can be an imaginary one, but there should be a boundary which clearly differ or which clearly make a distinction between the system and the surrounding. Okay, so I hope that is clear for you. Now the part of the universe except the system is called surroundings. That's what we have just told now. And if you consider system and surrounding together, that combines and gives us the universe. So universe, I told you, the system, boundary, and the surrounding includes the whole universe except that particular system. Okay, so surrounding plus that system will give you the whole universe. That's a very simple concept to understand, right? Now this is an example for clarifying the concept. So you can see the funnel. Inside the funnel there is a solution, and this funnel is closed, you can see that I am concentrating where? I am concentrating inside. I want to know what is happening inside this funnel. So my system is this region. This is my system. Okay, or I can say whole funnel is my system. And you can see that this glass boundary or the glass, you can call it as boundary or end portion of this funnel, this part is a boundary which separates the surrounding and the system. And the whole region surrounding the funnel considered as the surrounding. Even the observer also is part of the surrounding. Okay, so that's all about the system and surrounding. So with this example, you can easily understand what is a system, what is a surrounding, and what is a boundary. Now, types of systems. Yes, students, here actually in thermodynamics, as I have told earlier, it is what we are discussing is, we are discussing about the exchange of energy. That's actually what chemical thermodynamics deals is, the change in energy when a chemical reaction takes place. That's all about chemical thermodynamics. So, here we classify the systems into three, and based on what? We classify the systems into three based on the ability of the system exchange the energy and matter with the surrounding. Okay, we know that there is a system and there is a boundary, and surrounding that boundary or surrounding the system we have a surrounding, right? Like, so there is a communication between, there can be a communication between the system and surrounding. So their communication is in two ways actually. One is through transference of energy. System can transfer its energy to surrounding, and surrounding can transfer its energy to system. Similarly, system can transfer matter from system to surrounding, or surrounding can give some of its matter to system. So these are the two ways the system and surroundings communicate. Okay, they communicate by exchange of energy or transference of matter. So based on the ability of the system to exchange energy and matter with the surroundings, systems are classified into three types. The very first one is open system. See, I take an example, an open system as an open teacup. Let's understand, this is an open hot tea cup. We know that if this is open, hot tea, so obviously first, right, first will go outside. That means there is a transfer of matter, right? A transfer of matter. This hot tea, that the vapors will go. So matter is transferred from system to surrounding since it is open. And the system is hot. System is hot and the surrounding is cool. So there is a clear-cut difference between the temperature of the system and surrounding. Wherever there is a difference in temperature, what happens? The energy flows in the form of heat until the surrounding and system will have equal temperature. So if the cup is hot and the surrounding is cool, that means within the system the heat get transferred into the cooler surroundings until when both the temperature inside the system and the temperature in the surrounding becomes. So if you are considering an open system, we can see that there are two transference are taking. Both matter is transferring and heat is also transferred. So this is how we understand whether a system is open or closed. Is that clear? So this concept you have to understand that whenever there is a temperature difference, what happens? The heat energy from higher temperature body will move to the lower temperature body. Okay, like we know the electrons flow from higher potential to lower potential. Likewise, from high temperature to low temperature, heat energy flows. Is that clear? Please let me know in the comment section if it is clear for you. Right. Now, discussing about the closed system. If you consider a closed system like the same hot tea, now closed. Okay, closed means the vapors are not moving out. Vapors cannot move out. Closed. That means there is no transference of matter. No matter transfer. No matter transfer. And if this system is hot and surrounding is cool, what happens? Heat energy from higher temperature body close to lower temperature, there will be transference of, since heat can move through the boundaries, and especially these boundaries are called as diathermic. Have two types of boundary. One is insulated boundary, or you can say isolated or adiabatic boundary, and diathermic boundary. And those which enables the movement of heat are called as diathermic. The other one is called as adiabatic. Adiabatic boundary not allow the movement, not allow movement of heat. So here we are not taking adiabatic. Whenever we take the condition of adiabatic, we will clearly mention that the boundary taken is adiabatic. If not, the boundary will be diathermic. So diathermic boundaries always provide what? Always transfer heat through. So here there is transference of heat. Heat can be transferred. Heat is normally we use Q, the letter Q to represent it. So here what is happening is that exchange of only energy is taking place and no matter with the surroundings. Matter cannot be transferred since it is a closed system. So closed system, the vapors or the molecules cannot will be within the system, but the heat get transferred through the walls of the system. So it can transfer energy. So any system which can transfer energy, transfer only energy and not matter with the surroundings, are called as closed system. Hope this example is clear for you. Is pressure cooker also an example of closed system? Obviously, pressure cooker is also an example of closed. But we cannot completely say that it's a closed system. As it reaches to a particular pressure, the top portion, that whistle blows out, and what happens is that the vapors gushes out. So at that moment, the closed system acts as an open system. So actually, pressure cooker is a combination of both, the closed as well as, okay. So until it reaches to that pressure level, it is acting as a closed system. Once it reaches to that equivalent pressure level, what happens? It blows the whistle. What happens? Through the whistle, the vapors are coming out to the surrounding, That means now the pressure cooker is acting as a open system. So the component of now this is all about what we have done. And yes, yes. So isolated system means you consider a thermos flask. You consider a thermos flask. You know that we use the thermos flask mostly in collect hot water inside this and this thermos flask has an adiabatic wall. That means not allow the what allow the transference. So we know that the remains constant with that. So this what this adiabatic wall does is that completely uh, removes all the connections with the surrounding. So now the system do not have any connection with the surrounding. Okay, I told you the system have two types of connection. One is transference of mass and the other is transfer. But if you are closing the system with the adiabatic wall, it do not allow the transference of matter as well as it do not allow. That is all about isolation. Hope that is clear. So you may think that in thermos flask also, after some time, after one day, that the hot water loses its temperature. That happens. They ask that, sir, that case the heat might have transferred. That's why. Thing is, this adiabatic wall is not 100% adiabatic. This is a conceptual theory, or this is an hypothesis that if you have 100% efficient adiabatic wall, then no case of transference of. That's what you have to. But for time being, can take an example as hot water taken in a thermos flask for just one day. There is no much transference. So there will be a slight transference of heat. But actually we assume that there is no transference in order to understand that particular. Right. And in concise, this is the total system that we have discussed. You can see that open system, there is a transference of heat is there, transference of mass is there. That means mass means matter is transferred, heat is transferred. In closed system, there is no transference of mass, but yes, it is transferred. But in isolated system, here it should. And here the mass and heat, there is no connection with the sun. If there is no connection with the sun, call them as. You know that we have seen the COVID case. When a person is with what happens, ask them to go to isolation. What do you mean by isolation? Have to completely get. Why we are doing that? That the so that's the same term. In order to understand that this system have no connection. They do not transfer matter. They do not transfer. So that's all about three types of systems. Now, next term or terminologies that you have extensive property, and extensive properties are important topic. You have to understand what is meant by extensive. So I'll just read out that these are properties which depend on the amount of matter present. So in order to understand what is actually, I'll take a room. Just take a room. So this room has a particular, this room has a particular, this room has a particular, this room, this room, energy, this room has a particular, breadth, everything, right? So I'm, if I am also number of moles, particular room consists of certain number of moles also. If I am cutting this room in two equal half rooms, two equal half, two equal, you may not see it in a, so here consider a room having a density, mass, now what I am doing is I am cutting the two equal, I have to tell solve proper, solve proper. If I cut the room into two, the temperature cannot be half. The temperature will be, even if the temperature here is 20, then the pressure cannot be half. The pressure cannot be half because the atmosphere acting on the side or on the side are constant. Even if you cut it, the volume will surely will get. What about density? Keep density. Now we will move on. If you cut it into two, then mass will become right. Your volume will be half. What about number of particles? Number of particles will also will be half, no doubt. Number of moles. What about length? Early, if I am cutting from the center, then it will get L by 2. Now what about energy? Energy also depends on the number of particles, so energy also will be half. The concept of make it efficiency property are those, so those properties have got divided into two after cutting that rooms. Those properties are called as, you can write volume is density. Now let's discuss about density. My voice is buffering. Maybe I think your, I think it may be your network issue. I can clearly hear it here. Not a problem. Is there any issue? Hello, 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 hello. Hello, hello. Suffering a little. Okay. Hope that will not. Now it's clear. It was a small connection problem. Now it's clear, right? Ready. So, okay. so, so the extensive properties are those properties which upon the amount of matter. That means if matter is divided or if matter is reduced, that property will also change. So, but here you can see that the temperature and pressure, even after changing the matter, there is no change property, right? The property remains constant. There is no change. So, it is independent on the amount of substance or amount of matter present in the system. Let's take the case of density. So, density is actually, we know that it is mass by volume. So, if you cut it into two half, we know that the mass gets changed and volume also will be halved. So, what happens? These 2 and 2 get cancelled and mass by volume will again remains the same and density will not have any change. So, density is not an extensive property. In fact, density is what? So, you can write here that if two extensive properties, that is extensive property by extensive property by extensive is equal to what? That's an example. Perfect example is if I take density, then the numerator extensive property is mass extensive. So, mass by volume will give density. So, I hope your extensive and intensive property is clear. Only thing is, these are the properties which do not changes, or extensive properties are those properties which changes if the number of substances present or the number of matter present in the system changes. So, if you make changes in the number of atoms or number of molecules present in the system, and extensive properties will, because it is dependent on the amount of substance. Okay, and there are certain properties which are independent of the amount of substance. There are certain properties which are independent of the amount of substance. Such properties are called as processes. These are properties which are independent sorry, which are independent of the amount of matter present. Okay, and here you can see temperature, pressure, volume is not true, density, refractive index, molar heat capacity. Here I want to show you one more thing, that is in extensive property you can see here heat capacity, internal energy, all the energy, that is internal energy, enthalpies and entropy, Gibbs energy, all energies all are dependent on the amount of quantity. And here you can see the heat capacity, and if anything molar is added with that, then this extensive property will get converted to intensive property. Okay, that is heat capacity is extensive property, but molar heat capacity is intensive property, because there molar means 1 mole substance. So, if you want to find out the value molar heat capacity, then that particular system should contain 1 mole. If you are dividing that system and if that system do not contain 1 mole, then there is no molar heat capacity, then you cannot measure that particular property. Okay, so that is why we say molar heat capacity is intensive property. If you divide that molar, if you have 2 moles, okay, say if you have 2 moles in a system, and if you find the value of molar heat capacity, let's take an example, I'll explain that. If I have a system and this system has 2 moles, okay, and molar heat capacity, the short form, molar heat capacity kilojoule, molar heat capacity. So I divide the system and I got it to 2 systems, and each system contain 1 mole. Now what is the molar heat capacity? Molar heat capacity, is it 125? No, molar heat capacity 1 mole. Here there is 1 mole, so it will be, so even if it is 2 moles, molar heat capacity only consider the heat capacity. So if you divide that system and you are getting 1 mole, even then the molar heat capacity. So whenever you see the word molar, then understand that it's a intensive property. And you do not find that, that is not true. Think like what I have taught you. Consider a room, break it into 2, and which all factors are getting divided by 2, that all are extensive. All those that as to the problem. Okay, hope this is clear for you. Let's move on to the next. Now the other thing is state and path function. This is also an interesting thing. See, actually functions means nothing but properties. Functions are nothing but property. So properties means what? Like the properties of a system. What are the properties of the system? Temperature is a property of the system. Pressure is a property of volume, is a property of energy, is a property, enthalpy. All these are properties of the system. And heat, transfer of heat is a property of a system. Okay, and work done by the system or work done on the system are the properties. And state function means those properties which are independent of the way it has been. For example, how can I explain this? I can explain this by taking, see, a boy is standing here and he wanted to reach. So he is at A and wanted to. Boy started to walk like this. Another boy went like this. And another boy make a walk like this. So which boy have covered more distance? Obviously, we can say that the second boy have covered more distance and first boy have covered less distance. Okay, since both covered depends on the path they follow. But what about the displacement? What do you mean by displacement? Your starting point and your end point, just join it with a straight line, and that the length of that line will be from your starting point and your end point, join with the straight line, and the length of that line will be the displacement. So displacement is not depending on which path you have followed. Okay, but think about the distance. Distance, in the case of distance, what is happening? The distance is varying depending upon the path followed by the system. Okay, we have two systems here. One system followed a path A from B in the form of a red line, and the other system followed the path in the form of similar to that of the black line. So system A, or the first system followed the less distance, and second system followed the more distance. But asking about the displacement, it is independent of. So displacement is a state function and distance is a path function. I hope state function and path function is clear for you. Okay. Similarly, have state function and path function. Thermodynamics, you can see that I normally say students that you only study path function. If you study path function, then rest everything is state function. Okay. So what are path functions? Only two properties are path. One is heat, there is work. So heat and work are path functions. They depends upon the path. If the path is more, the work done is more. If the path is more, the heat transference is more. Okay. If the path is less, heat transference. The path is less, the work done. Okay. So it is dependent upon the path. Okay. But temperature, whether it's the path is from north to south or east to west, whatever the path, temperature remains, the pressure atmosphere remains, volume remains. It is not dependent upon how the particular temperature, whether you increase the temperature by burning or whether you increase the temperature by by churning. Okay, what do you mean by churning? Churning means taking a stirrer and stirring it thoroughly, called as churning. If you churn it, obviously the temperature will increase. Whether you do it in that way or whether you heat it and increase the temperature, no worries, the temperature will give. It does not depend on how it has been. Okay, so that is the case of state function. Only study what is path function. Every other property, there are two path functions. One is work, the other is heat, and all the other properties are. Hope that is. Now coming on to very important topic, that is. So what do you mean by internal? It is the energy passed by a body. See, if you take a body, my body, okay, I have lots of atoms and within my body. Okay, so these particles, the total energy of of all the particles, the internal energy. So what are the different types of energy that these particles have? These particles have a translational motion. That means they should have a translational kinetic energy. And these particles will rotate. So it is having rotational kinetic energy. These particles will vibrate. So they have vibrational kinetic energy. And these particles will attract or repel each other. That means they have electronic energy. And certain particles will get attracted within each other. That means they have nuclear energy. So all these energies, if you sum it, every minute energy given by each particle, if you totally take the sum, that is the internal energy. That is clear. Okay. So you take the total number of particles and if you sum all the possible energy, that will be. And understand, because of this, actually we cannot accurately measure. Be thinking why? Because we cannot accurately measure the vibrational energy. small value for it can be measured. Translational can not measure. For a macromolecular system, we can measure, but in case of molecules, so the internal energy cannot be measured actually, but change in internal energy can. Difference or the change, the difference in internal energy or the change is actually the energy that during a reaction. That released energy can be calculated by using. So change in internal energy can be measured, but internal energy. Why internal energy cannot be measured? Because you cannot measure all these values, right? Is that clear? Voltage. So the unit of internal energy is kilojoule. Okay. Right. Okay. Now the internal energy of the system changes mainly in two ways. How it changes? It changes by the transference of heat or by doing. We know that I am now in class. That means I am doing work. So my energy is decreasing. So there is a change in internal energy. So this change in internal energy happens because of what? Because of me doing the work. So by doing work, internal energy, and also by transference of heat, energy. That means there are two ways of transference of heat, ways of. Here, if you consider a system, the heat is transferred from the system to surrounding, or heat can be transferred into the system from surrounding. In both the cases, internal energy. In the first case, what happens with the internal energy? Internal energy. In the second case, the internal energy. So, in whichever case, in those cases where internal energy is decreasing, that case is represented by a negative. So, if heat is transferred from system to surrounding, then we denote it by minus. Why minus Q? Because if that process is taking place, the internal energy, okay, if the internal energy is increasing, that means if the heat is transferred from surrounding to the system, that the internal energy is increasing, that heat is called as flux. Okay. Now what about work? Similarly, we are considering a system, take this as a, and there are two types of work. One is the system can do the work to the surrounding, okay, or the surrounding can do work on the system. Work done on the system is there, work done on the system, work done by the system. We know that if the work is done by the system, if system is doing work, then what happens is that internal energy decreases. If internal energy is decreasing, then we put that work done by negative. If work is done on the system, that means surrounding is doing work, means he is transferring his energy to the system. That means there the internal energy is. In that case, the work is denoted. So this is how you have to represent the work as well as regards to direction. Okay, it is transferred from the system to surrounding. Minus Q is transferred from surrounding to system, that is work is done on the system plus by the system. It all depends on whether by doing that particular process, whether the internal energy is increasing or decreasing. Based on that, that is clear. Now, the last topic, first law of thermodynamics. So, what is this law says about? It is same as the law of conservation. That is, says that energy can neither be created nor be destroyed. Or it has another definition that the total energy in the universe always. So, if you consider the whole universe, the total energy, no, there is only transference of, there is only the change of form of energy. Apart from that, total value whole universe, that is similar to what we have. So energy cannot create, but you can transfer or you can convert one form of energy to, that's all what we can. Similarly, we cannot destroy energy. We can convert that one total energy. You are considering an isolated system. In an isolated system, there is no connection. So what happens with the total energy of that isolated? So there is no way of transference of energy from an isolated surrounding. So that is the third definition. Total energy. So mathematically, you can that delta U, the internal energy, U plus delta. So always internal energy. Okay. So that means total energy of the universe constant, but not of form of energy. There is no new energy cannot be or existing energy. This mathematics very very no doubt about delta U, delta U, delta U is changing in plus. So if you are considering the expansion work, then you can by P delta U, that work done is equal. If you are doing an expansion work, I'll put it. So if the expansion work means the work is done by the system does the work, then expansion. If work is done on the system, then compression. So if you are taking the considering the system is doing work, then that work. So that is all. So students, topic that we have about today here for you in the comment section, all the big terms and field of thermo. Please and add the